Hey, what's going on, guys? Welcome to example 3 of 9.2. I've done some of the workout because it's not too exciting watching me expand this out. So I've expanded this out up to the point where it helps us look for the pattern to solve the question. They're looking for the coefficient of the term with x to the 10th for the expansion of x plus 2 to the 15th. Notice some differences. This binomial only has one variable. Doesn't really change our approach. It just makes the final answer only have one variable in it. The other thing is I've done the expansion out up until the x to the 10th that they're looking for. ... The ellipses just represent all the other terms that I didn't bother expanding because they're not very relevant to the final answer. But if you take a look right now, what I want you to notice is that when I've expanded it out, that this is actually the sixth term. Now, if you want to pause the video right now and just copy all this down, by all means do that, and I'll continue in a second. All right, you've unpaused the video, hopefully, and copied this down, or maybe you paused it ahead of time. Anyway, let's see. So we now know that this term right over here is the one that we're looking for. It has the exponent 10 for the first term. Now, one thing to keep in mind is that this would be the sixth term. All right, and if I have, let's say, the seventh term or the eighth term, what I want to do is make sure in my mind I understand that the sixth term helps me determine which r it is. Now, this question specifically said, hey, get me the coefficient for x to the 10th, but traditionally speaking, I like to emphasize which term number I'm looking for. Now, this exponent, when you first do the problem, is only gonna be 10 or 11 or 12, but there are problems where it's not an x. Maybe it's x to the third being plugged in, and then you're gonna have to raise that to the 10th. But if this is a 10, well, how does a 10 get me a 5? Well, it's pretty simple. Whatever this number is, all you have to do is subtract it from 15 to get that, right? So to get the r, all you have to do is do 15 minus 10. And that gets you your r value. But again, that's a very specific algorithm. As you can tell, there's another pattern here, that the two exponents will all add up to 15, right? 11 and 4, 10 and 5, 0 and 15, 15 and 0. They all add up to 15. So there's going to be patterns with the exponents and the n and the r that is true for all the different ways they can ask you. But really, I like to relate it to the term. So the sixth term is going to have an r value of 5. And why is it 1 apart? It's because you're starting with 0. So if you take computer science, in comp sci, the index always starts at 0, or typically starts at 0. And so 0, 1, 2, 3, 4, 5 for the r's actually indicate an r value of 5 is the sixth term. So if I ask you for the 10th term, then your r value is going to be 9, right? And notice that this exponent matches with that. So then if this was a 9, then this one would be a 9, and then this one would be a 6, because this would have to add up to 15. That's binomial theorem. That's how these patterns work. It's not, and you're not going to get, it's not like you're taking tests for these at this moment, but those are the patterns that we're sort of looking for, so we can avoid all of this and just get straight to that. So let's just get straight to that at this point, now that you see that pattern. So let me just write that as a note. Term number equals, let's see, r plus 1. All right. Or you can say r equals term number minus 1. Right? And this is all because r starts at 0, okay? Or r starts with 0. Anyway, let's simplify 15, choose 5, x to the 10th, 2 to the 5th, right? And this you just throw into your calculator. I've done this before. So if you do 15 choose 5, you'll get 3003. X to the 10th. 2 to the 5th is 32. And at the end of the day, you just multiply it out. You get 96096 x to the 10th. And that's your coefficient right there. Times x to the 10th. So 96,096 is your answer. I'll see you in the next example.